So let's talk about some general practices for graphing absolute value functions. So we're thinking in terms of a parent function, which is how we describe functions before there are any transformations put onto it. So what we're looking at here is a parent function of just absolute value of x, which we graphed in that last video. So be sure to go back and look at that, as that's kind of our starting point. So the key with that is that it has that corner at 0, 0. And then we saw two slopes. So we have two linear functions coming together at that corner. One has a slope of -1 and one has a slope of +1. So we're seeing something like this come through for our parent function. So we want to keep those pieces in mind as we move to these transformations of our absolute value function, so that we can see how do we graph these based on the properties of the parent function, but applying our transformations. So what we're going to do here is just first look at the calculations with our absolute values. So like plugging in a -2, so we're going to have 2 absolute value -2 minus 1 minus 3. So that's a 2 times, so that would be an absolute value of -3, which is +3 minus 3. So 6 minus 3 for a +3. Then we could do the same thing with a -1, plugging in, so we'd have 2 times the absolute value of -2, which is a +2. So 4 minus 3, which is 1, and then we just keep going to fill in our table. So that one would be a -1, and then plugging in +1, that'd be a 2 times 0 minus 3, so -3, and then +2. And then we start seeing some repeat values. So that kind of tells me that we've passed the corner of the graph at some point. So this would be a 2 times 2 minus 3, which is a +1, and then plugging in a +4. So a 2 times 3 minus 3 for a +3. So I'm seeing here is this nice symmetry, and that has me thinking that this 1, -3 is probably our corner, because that's where we start switching back to our repeated y values. So we end up with these coordinates here. So let's go ahead and graph those. All right, so -2, +3, -1, +1, 0, -1, 1, -3, 2, -1, 3, 1, 4, 3. Okay, so here is our absolute value function that we're graphing. So let's talk about some characteristics that we're seeing. What coordinate is the corner? And that's going to be at our 1, -3. So if we go and look at our function, where we could see those values coming through relates to our vertex form of the quadratic functions. So we see this -1, -3. So what we could do is always translate to the corner, again switching where that's a -1, it would be a +1, and then that -3 would stay a -3. So given the original form, that'll show us the corner that we're working with. Does the function open up or down? It opens up. And in terms of our original function, what we're looking at there is this value multiplying with our absolute value. Because that's positive, it'll be opening upward. If it was a negative value, we would be opening downward. what are the slopes of the two lines? So what we could see is on the right-hand side, we would go down to right 1. So I'm seeing a slope of -2 there. And then over here, I'm seeing a slope of +2. So what are the slopes of the two lines? We're seeing 2 and -2. And in terms of our original function, that is coming through with the 2 out front. That's going to tell us about our slope. So that piece tells us two things. One, whether it's opening up or down, whether it's positive or negative. And then it's telling us the slope that we're working with. So again, this is all coming from our transformations, like this is our vertical stretch. And then it being positive or negative is all about if there's a reflection or not. So if there's no reflection, it stays opening upward. If there is a reflection, it opens downward. And then this is a combination of our horizontal and vertical shift that we're working with. So it all comes down to those transformations, but we can also kind of use these as shortcuts to tell us about how to graph that function. So let's say I'm given a function and I want to come up with what is the actual function notation that we're working with. So what I want to fill in the blank for is what's my number out front and what's the coordinate of the corner that we're working with. So if I go to the corner here, we're at the coordinate -2, -3. So again, next to x, we switch the sign. So where it's a -2 in the coordinate, I would go +2. And then the y coordinate stays the same. So -3 would stay a -3. It's opening upwards, so that tells me that we have a positive value multiplying out front. And then I'm going to go looking for the slope. So I'm just going to go ahead and grab 2 coordinates, which that looks like a nice slope of a +1. So we go up 1, right 1. Just going to check my units and everything. Yep. So that would just be a +1, which we don't even need to write there, but we do want to check that each time. So that if that had a slope of like +3, we would put a +3 there. Now notice if we looked over here between 2 points, I would have seen a slope of -1, but just keep in mind that since it's opening upward, that value out front has to be positive. So you're always going to have a mixture of negative and positive slope with these, and just make sure you're using the correct one based on whether it's opening upward or downward. Okay, so with that, let's get some practice with graphing these. So where I'm going to start is with the corner. So this would be a +4, -2. So let's go ahead and graph that. So 1, 2, 3, 4, -2. So there's the corner. And then I can see it's going to be opening upward, and we're going to work with a slope of 3. So as I go to the right-hand side, I'm going to follow a slope of 3 here. And then as I go to the left-hand side, I'm going to use a slope of -3. And we should always have this nice symmetry coming through. So there's one side, there's the other. So corner, notice whether it's opening upward or downward, and then use that slope that's coming from that first value. Okay, and go ahead and pause the video and try the rest of these on your own. Hopefully these should be familiar with how we kind of worked with our quadratic functions. So corner here would be -1, -2. So -1, -2. It is opening upward, and we're going to work with a slope of 2. So following a slope of +2, going up to the right, and negative from the left. And then draw 2 nice straight lines here to connect them. All right, 2 more scenarios here. So corner of +4, +2. 0, 1, 2, 3, 4, 2. This is going to be opening downward, and we're working with a slope of 3. So now as I go to the right-hand side, I'm going to be using the negative slope of 3. And then as I go to the left-hand side, I'll be using the positive slope of 3. So I just switch which side was my negative and which side was my positive slopes. And connecting those. And that should match nicely. Again, you could graph these in Desmos to double check that it is lining up. Okay, last one here. So corner will be a -3, -2. It's a little too far there. -3, -2. It is opening downward, and we're going to be using a slope of 3. So going to the right, I'm going to be going that negative slope. And to the left, we'll be using the positive slope. And connect those for our absolute value function. Just to talk about domain and range real quick for each of these, for all of them, domain is all real numbers. Absolutely all of them. Range is a little different. Range, we need to look at where that corner is, and specifically we would look at the y value of the corner. So that would be our starting point, and then because it's opening upward, we would have all values above. Same thing with this one, our y coordinate of -2, we'd include that, and then all values above. When it's opening downward, we go to that y coordinate, and we would have all values below. So the range adjusts based on the y coordinate of the corner, along with whether it's opening upward or downward. But domain is always the same for them of all real numbers.